Hello, my name is Sprite Olson. I'm a postdoc at the Virginia Tech Center for Ecosystem Forecasting. In this Vera Forecasting Challenge tutorial, I'm going to talk about how you can automate your forecast. In this video, I'm going to introduce a simple workflow automation. And we're going to talk about how to set up a GitHub action. We're going to be using GitHub Action as well as Docker in this tutorial. A couple of prerequisites before you dive into automating your forecast is that you need to have a GitHub repository that includes a complete forecast workflow. The workflow I'm going to show you assumes that you've forked from a Vera forecast example, but many of the tools that I'm going to demonstrate will be applicable if your code is in a different repository. You just might need to make a few changes. So just as an introduction, why would you want to use workflow automation using GitHub Actions? The first is to ensure reproducibility. The workflow that I'm going to show you uses a containerized environment. So these are containers of software and code that is predictable and doesn't change and is stable, and ensures that your workflow works the same every time, which takes us into our second step in that this workflow allows you to undertake an iterative forecasting framework. The GitHub action that I'm going to show you runs every day, meaning you can update your forecast and run the same workflow every single time. Using GitHub Actions also allows us to outsource our computation. This has positives and negatives in that we're not using our own PCs or computational environments locally, but the cloud computing does mean that there are limits on the amount of memory and processing power available. This shouldn't be a problem for a majority of people, but if you're using a very memory-intensive methodology, you might need to consider other additional methods or extensions to the GitHub Actions framework. So now we've talked about why we might want to do this. The next is the how. So hopefully, if you've followed along with the tutorial videos, you'll have run through the tutorial. Maybe you've had a go at developing your own forecast and you're ready to run this every day to produce a set of iterative forecasts. Here is my GitHub repository. This is a fork of the Vera forecast example, but it's in my organization. I've also included all of my code in my forecast code repository. If you forked the Vera forecast example, this will already be in your repository if you want to take a look, and there's instructions here that you can follow along, and I'm going to discuss. But all of my code to produce a forecast, it reads in the targets, it gets the NOAA data that I need, and it produces a forecast and importantly submits it to the challenge, is included in this R script here, run forecast. I decided for my forecast that I wanted to write a function. My function is generate example forecast, and if you go into the forecast code and into the R, you can look at what this code actually does. You'll recognize that a lot of this code is similar to what's in the tutorial. I took most of that code and put it into kind of a simple R script. You can see here the different sections, getting targets, getting weather, fitting the model and generating the forecast, which will be familiar with you if you followed the tutorial. If we go back to the forecast code directory and the run forecast script, you can see that this includes all of the code needed to produce a forecast and submit it to Vera. This is the forecast generation, which I just showed you the code for this particular function that I wrote. We write the file, and then here is the submission step. So we have a full forecasting workflow in this code. The next thing we want to do is want to be able to run this in a reproducible, iterative way. And the automation framework that we're going to use includes two things. The first is a Docker, which we can think about the environment that this brings. A Docker container is a standard unit of software that packages up both code and dependencies, so the application is going to run the same way every time in any computational environment. So I could take a container and run it on my computer, and it would run exactly the same on anyone else's computer. We're going to use a container from the Rocker project, which is a Docker container that already has R installed, as well as some pre-installed packages. The Vera Challenge has its own container, its own Rocker container, that also includes Vera Forecast Helper package, which you'll use to submit your forecast, plus the Tidyverse and other commonly used packages. This is the location of the image or the container that we're going to use. The next thing that encompasses our automated workflow is the platform. We're going to be using GitHub Actions. There are a number of different automated tools that you can use, but the one I'm going to demonstrate is GitHub Actions. This allows you to run a particular workflow based on a trigger. This might be a time, which is what we're going to use. We're going to run it at the same time every day, but you can also use different triggers. Maybe you want to run a workflow every time something new is pushed to a repository, or every time someone opens a pull request. You can learn more about GitHub Actions at this link here. There's lots of possibilities for automating workflows within GitHub Actions. To ensure a GitHub action starts and runs correctly, you need to give it a series of instructions. These are listed in a file called a YAML file. And if you forked the Vera Forecast example repository, this will already be present in this directory in the main repository. I'll show you in a second. And this YAML file includes a series of instructions that are going to open a virtual machine, and they're going to tell it which steps need to be run to submit our forecast. So I'll just show you the YAML file and explain kind of what each of the bits mean. So if you navigate back up to the top of the directory and go into the GitHub workflows directory here, if you're not working from a fork of the Vera Forecast example, you will need to make this folder exactly as it's written here, .github/workflows. And then inside here, we have this YAML file, which is currently called submit forecast YAML. Inside here are the series of instructions needed to automate the workflow. This on describes what our trigger is. Now, we're going to use a cron trigger, or like a time. So for this particular example, it's going to run every day at 1300 hours or 1 p.m. UTC. So it's going to run at 8 a.m. Eastern time for me, just before I get to work. And it's going to run every day. The next step, this jobs chunk, is going to tell us what is going to happen in our automation. So the first thing it's going to do is going to open a Ubuntu machine, and it's going to use a container image. So this is the little package of software that we've told it we want to use this to run our code. And so we're going to use the image for the Vera Forecast that includes the packages that we need. The next are a series of steps. So once that image is open, we have an environment. What are we going to do with it? The first thing is going to check out the repository. So this is an action that is kind of pre-made that multiple people will be using. It's reusable. And this basically takes the GitHub repository from the URL and brings it into this virtual machine. So kind of like you would clone the GitHub repository into your local environment, that's what's happening here. And the next step is to run our automatic forecast submission, which is going to run this R script function here, and then it's going to point to the R script that we want to use. Now, importantly, this is the file path exactly of where your script is. So if we go back to, so it's looking for forecast code run forecast. So if we go back to here, it's going to look in here and we have forecast code and we have our run forecast. If you've renamed the script, if it's in a slightly different location, you need to make sure that your YAML file includes the location of that script that you want to run. So here's, again, this is reproduced if you don't have it. If you need to make a new YAML file, you can copy this code here. Make sure you change any file paths that you need to. And you also need to make sure that the indentation is the same as is listed here. This is really important, otherwise it won't work. So if you have forked the repository from Vera Forecast example, then it should all be there, ready to go. If not, go ahead and make that YAML file. And once you've done that, and you have the YAML in the correct place, the first thing you want to do is enable actions. Actions is going to be listed in the top thing here. If you click on it, you can see here that my workflows are not currently being run. This is kind of the default for forks of a repository. They will be disabled, so you want to go ahead and enable them. Again, we still don't have anything listed here, but you'll see now that our GitHub workflows includes that submit forecast YAML. You can see that it's currently disabled, so if I go ahead and click on this, I can enable that workflow. I'm going to click that. You can see now it's told us that our workflow has been enabled. And you'll remember that in our YAML, our on, when is it actually going to run, was based on a time. And it's not currently 1 p.m. UTC here, so I will have to wait until 1 p.m. UTC, but we can also test our workflow by running it manually. So there's this run workflow button here. You can click that, click the green button, and you can see that it's been requested. It gets put into a queue with all the other GitHub actions that are being requested around the world until there's kind of machine space available. Once it's been started running, you'll see this orange dot appear. The color of the dot will tell you whether it's in progress, which this one is here, whether it failed, it'll be red, or whether it was successful, and it'll be green. If you're interested in knowing what's happening, you can click on the workflow here, and it'll see how long the time has elapsed since you started the run. You can also click the workflow file to view what's being run. That's just the YAML instructions that we already looked at. So if I click on this, you'll see each of the steps that are listed in our YAML file. So this is just launching the job. Took a second for us to get out of the queue. This is the first step of it initializing the container. So it's looking for that image that we gave it, and it's going to set up an Ubuntu environment. This is a lot of information that you don't really need to worry about, but you'll see here, this is it making the container that we need. Once that is successfully run, we get a tick. And the next step, as listed in our YAML, was to check out the repository. So to get those GitHub code into the virtual machine. You can see here this was also done successfully, and the last step was to run our forecast, which is that R script. And you can see here that what is returned in our GitHub action workflow run is what it would be returned in your console. So if you are like printing data frames, or maybe anything that's going to turn up in your console is going to be shown here. So you might want to put messages in. You can see here I've got a few messages in. It says like, now I'm getting the weather, and now I'm fitting the model. And so that's useful if it fails for some reason, that you can find out at what point in the script it fails, because it's going to run the whole thing. You can't run it line by line. And so you can see here, this looks like it was all successful. It said that, yes, it was in the right format. We submitted, we get a party parrot, everything is good. And if I go back to the summary of every run that has happened with this workflow, you can see that this one that I just ran manually is now green. We successfully submitted a forecast. And so the next time this will run will be either when I run it manually again, or when the trigger occurs based on the cron that I set initially. So that is it. Hopefully you've now seen how to automate your forecast, and you've completed the Vera Forecast Challenge tutorials. If you have more questions about how to get involved, you can visit the Vera Forecast Challenge website at theLTREBreservoirs.org. And if you're interested generally in the data that is going into the Forecast Challenge, again, this is available on the LTREB reservoirs.